So exam 1, number 3. So the question is, how many millimeters are there in a mile? So start with 1 mile. And we know that 1 mile is 5,280 feet. And we know that there are 3.281 feet in a meter. And we know that 1 millimeter is 1 times 10 to the negative third meters. And so now the miles are gone, the feet are gone, the meters are gone. And so yeah, if you take 5280, this is the same as times 10 to the third divided by 3.281. You get something like 1.61 times 10 to the sixth. Any questions about that? Any other questions on the test you'd like to see? Yeah. Yeah, sure. Okay, so the last one. Yep. So this is the one, there's a hill, and there's a starting point for this man walking back and forth. There's a mailbox here, and the distance between these is 3 meters. And up here is the house, and the distance between these is 7 meters. And the path, he starts here, goes to the house, back all the way to the mailbox, and then back all the way to the house. For part B, it says the 0 position is where the man starts. So this is our 0. And the positive direction is towards the mailbox, so this is positive. And so now we can label all the positions. If you start at 0 and go in the positive direction 3 meters, you're at positive 3. And if you start at 0 and go in the negative direction 7 meters, you're at negative 7. And the times that we're dealing with, it says the 0 time is 10 seconds before the man starts walking. So he starts walking at time 0. No, he starts walking at 10. That's what I just said. And then it takes 10 seconds to get from the starting point to the house. So 10 plus 10 is 20. Then it takes 15 seconds to get to the mailbox. So 20 plus 15 is 35. And then it takes 20 seconds to get from the mailbox to the house. So this final point is 55. And let me write out a table for this too. So here are the times and here are the positions. The first time is 10, and that's associated with position 0. The second time is 20, and that's associated with position negative 7. The third time is 35, and that's associated with position positive 3. And then the last time is 55, and that's associated with position -7. So with this graph, you have a 10, 20, 35, and 55. So 10, 20, 35, 55. And the positions we want are 3, 0, and -7. And so the graph looks like this. We're at 10, 0, 20, -7, 35, +3, and 55, -7. Any questions about that one? Any other problems anyone wants to see? That's right. Yeah, so if the final is your worst exam, then your final still counts as itself, and all your first 4 just count as themselves, you know. Any other questions about the test? Yes. Okay, well, last time we were working on free fall problems. Does anybody have any homework questions? I think I assigned a couple of free fall questions last time. In D2L, if you go to content and then the practice problems, and the assignments themselves are in the announcements. It tells you what numbers you should do which day. Yeah, I think most of them did turn out being even. I think there might have been number 11 too or something, but I think we're just done with that whole set on 1D kinematics now. So I was just going to spend today. Yes. Sure. Yeah. Do you happen to have it with you? Questions? Anybody? Okay, so this is 1D kinematics number 7. Yeah, please. Okay, so it says a ball is rolled up a ramp. And at one instant it has a speed. So the ball goes this way. It's one location, it has a speed of 4 miles per hour. And after 0.8 seconds, its speed is 1.5 miles per hour. And we want to calculate the acceleration. What's the distance between these two? So how far did the object roll? And then convert your answer from part B to kilometers. We have some time units of hours, some time units of seconds. So I'm just going to start out by converting everything to SI units. So 4 miles per hour. 1 mile is 1,609.344 meters. 1 hour is 3,600 seconds. Four times 1609. Okay, so this is at that first location, speed is 1.79 meters per second. And at the second location, 1.5 miles per hour is 0.67 meters per second. Okay. So the first thing we have to do is make those 4 choices. We have to choose our instant for time equals 0, our instant for time final, our 0 position, and our positive direction. I'm going to, since I already have a sort of a little drawing of what's happening in this problem, I'm going to draw my 0 position and positive direction on here. So it doesn't matter which one of these you choose, but I think I'm going to put my 0 here at that first location where we know the speed is 4 meters per second or 4 miles per hour, and the positive direction this way, in the direction of motion. And now, what do you want to choose as your time equals 0 instant? Yeah, so time equals 0 is going to be the instant when the speed is 4 miles per hour. And what do you want to choose as your time final? Yep. And I chose the 0 position. So I chose my 0 position to be the ball's location when time was equal to 0. And anytime you do that, I mean, it has a nice little benefit. It always makes your initial position equal to 0. So 0 position is the ball's location equals 0. And another way, like just another way of wording this statement here is that position at time equals 0 is 0. And the positive direction is the direction of the ball's motion. And now we can think about what we know and what we want. Do we know the elapsed time between time equals 0 and time final? We do. It says that it takes 0.8 seconds to get from this one to this one. So T final is 0.8. Do we know the acceleration? Recently, we've been doing a lot of free fall problems, and in those, you always know the acceleration. But remember, for free fall, the object can't be touching anything. So if it's rolling along a ramp, rolling along the floor, anything like that, it's not free fall. We don't know the acceleration. That's something we're trying to find. That's what we're asked for in part A. Do we know the position at time equals 0? Yep. Do we know the position at time final? That's one of the things we're trying to find later, I think. How far did it travel? But for now, if we don't figure that out, that's fine. So we'll just leave it off. We know the velocity at time equals 0? Yes. We know the speed is 1.78. Is that what I said? Yeah, 1.79. So to get the velocity, it's the speed, and then the sign of the velocity tells us the direction it's moving. Is the ball moving in the positive or negative direction? Positive. So VI is positive 1.79 meters per second. And then do we know the final velocity? Yeah, I think I heard you all say, yes, we do. That's correct. It's positive 0.67 meters per second. All right, so is there one of those 3 constant acceleration equations that works with this, that has acceleration, and anything else in it is known? Let's see. So for this one, we know the time. So I think the one that we can use here, because we don't know we do know V final. We don't know final position. So I think the one that we have to use is the one that says V final is equal to V initial plus A TF. So we have 0.67 meters per second is equal to 1.79 meters per second plus A times TF, so 0.8 seconds times A. So I can subtract 1.79 meters per second from both sides, and we get 1.12 negative meters per second is equal to 0.8 seconds times A. And then divide both sides by 0.8 seconds. So we have 1.12 meters over seconds divided by 0.8 seconds is equal to A. And you get A is equal to 1.4 meters per second squared negative. Does it make sense that the acceleration is negative? How can you make sense out of that? Well, the whole time the motion is in the positive direction, so the velocities are positive. The thing's slowing down from 4 miles an hour to 1.5 miles an hour, so the acceleration has to be in the negative direction, opposite the velocity. Okay, now the second part of the question is we want to figure out how far it rolled in those 0.8 seconds. Is there any reason to change any of our 4 choices about the coordinate system and the 0 position, positive direction, that stuff? No, those 2 instants are still what we're working with, and there's no reason to change the 0 position or positive direction. So all these things are just going to be the same. And that's good news when everything stays the same, because then everything you knew before, you still know. They all have the same values if those four choices are the same. So what do we know? We know time final is 0.8. Now we know the acceleration is negative 1.4 meters per second squared. The initial position is 0. The final position is what we're trying to find. The initial velocity is positive 1.79 meters per second. And the final velocity is positive 0.67 meters per second. We're trying to solve for PF. I think you could use the equation that starts with PF, or you could use the equation that starts with 2A. So I'm going to use this one. PF is equal to PI plus VITF plus 1/2 A TF squared. So PF is equal to 0 plus 1.79 meters per second times 0.8 seconds plus 1/2 times negative 1.4 meters per second squared times 0.8 seconds squared. And so PF is I get 0.98 meters. Does it make sense that PF is positive? It does, because through the whole motion, the object's moving in the positive direction, and it starts at 0, so it needs to be positive. And then the last thing is to give the answer to part B in kilometers. Okay, well, 1 kilometer is 1 times 10 to the third meters. So we start with 0.98 meters and then multiply it by 1 kilometer over 1 times 10 to the third meters. And you get, so I'll write it first as 0.98 times 10 to the minus third kilometers. And then if I make the magnitude of 0.98 bigger for scientific notation, I have to make the magnitude of times 10 to the minus third smaller. So I'm going to make this 9.8 times 10 to the minus fourth kilometers. Any questions about that? Any other homework questions you want to see? Okay, well, let's start with this one. So as an example, let's do number 7 again. but different choices for the zero position and positive direction. So the ball's going to go going this way. It starts out at 1.79 meters per second speed, and here it's at 0.67 meters per second. This time, let's say that our zero position is here, and the positive direction is this way. So first, what's the acceleration of the ball? Okay, so see if you can work through that with this choice of zero and positive direction. Talk to each other as you go, compare steps as you go. Ask me questions if you get stuck, and then after you work on it for a while, I'll go through it. But all of the, we already have a bunch of answers from the first time we went through. So all of the answers for this one have to match the first one according to, certain rules. Some things will change, some things will stay the same, but we want to just sort of make sense out of the comparison. Okay, go ahead. Okay, so for this one, so we're still going to make these choices. And time equals 0 still has to be the instant that the speed is 1.79 meters per second. That's the 4 miles per hour. And time final is the instant that the speed is 0.67. Now these are changed. So position equals 0 is the ball's location. When it's at a speed of 0.67. And the positive direction is opposite the ball's motion. Okay, so do we know time final? Yeah, that's given. Time final is 0.8 seconds. Acceleration is what we're trying to find. The initial position. So what's the position of the ball when time is equal to 0? Last time we did it, it was equal to 0. This time, it's some unknown distance in the positive direction from the 0. So we don't have an answer for that. The initial, we don't have that. But if we can find the acceleration without getting that, that's fine. P final now is the one that's equal to 0. And then the velocities. Do we know the velocity of the ball when time is equal to 0? Well, we know its speed is 1.79 meters per second. But notice that now the direction of motion is in the negative direction. So the velocity at time equals 0 is negative 1.79 meters per second. And then at the second point, the speed is 0.67 meters per second. It's still moving in the negative direction. So VF is also negative 0.67 meters per second. And now we're looking for an equation that works with this stuff. We can use this one. And if you put it together, it says negative 0.67 meters per second is equal to negative 1.79 meters per second plus 0.8 seconds times A. Add 1.79 meters per second to both sides, and you get positive 1.12 meters per second is equal to 0.8 seconds times A. And so 1.12 meters over seconds divided by 0.8 seconds is equal to A. And so A is equal to positive 1.4 meters per second squared. Well, yeah, if we assume that we'd already done the problem. My thinking on this is let's pretend we didn't do it and just start over again with these two values. Yes, you're right about. Can you guess? Yes. Yeah. So now you should guess the distance and see if your guess is right. I want to say one thing before we do part B. Notice that so we had different values, different signs for the velocities, and a different sign for the acceleration. But if you think of all those things as magnitudes and arrows, if you think of it being just his acceleration being a magnitude of 1.4 meters per second squared and just a finger pointing in the right direction, this all says the same thing that it did the first time. Okay, and that's an important idea. So we still have so the velocity is 1.79 meters per second in this direction. It just happens to be negative now. And the velocity at this instant is 0.67 meters per second in this direction. And the acceleration is 1.4 meters per second squared in this direction. And that all agrees with what everything said the first time we did this problem. Okay? So if you think of everything as a magnitude and an arrow, things don't change because of the direction. But the signs can change because we change what direction the sign positive refers to. Okay. So now we want to figure out how far it is between these 2 points. So see if you can work through that with the new. So what's the distance the ball rolls in those 0.8 seconds? Okay, so we still have the same values for these. We know time final. The acceleration we just calculated. So that's positive 1.4 meters per second squared. Positive this time means down the ramp. The position at time equals 0, we don't know that, but we do know the position at time final. So really what we're trying to find in this one is the initial position. P final is 0. The initial velocity is negative 1.79 meters per second, but that still means a velocity up the ramp. We just changed the direction of our positive. And V final is negative 0.67 meters per second. And so the equation that works here is the one that says PF is equal to PI plus VI TF plus 1/2 A TF squared. So we have 0 is equal to PI plus negative 1.79 meters per second times 0.8 seconds plus 1/2 times positive 1.4 meters per second squared times 0.8 seconds squared. And so 0 is equal to PI plus well, this one's negative 1.43 meters, and then plus 0.45 meters. And so if you add 1.43 to both sides and subtract 0.45 from both sides, you get that PI is equal to positive 0.98 meters. So what that's saying is that the position of the ball at time equals 0 is 0.98 meters down the ramp from our 0. Any questions about that? No, so what we calculated was a position, and then you just have to interpret that position. Usually that's just a matter of just taking the absolute value. But position has always been directed. That's right. Yep, just not distance. Yep. Okay, let's do one more. Okay, so let's say that this guy's standing up on a step ladder. You're not supposed to stand on the top rung, by the way. It's just the more you know. But this guy is, because he's stupid. Okay, so he throws the ball down towards the ground. From a height of, how high do you think that should be? That guy's huge. Look how long his arm is, too. That helps. Let's see. So let's say 4 meters. And the ball takes 0.4 seconds to hit the ground. what was the speed of the ball at the instant it's thrown? Okay, see if you can work through that one. Go through this. All right, so we have to choose these four: time equals 0, time final, position equals 0, and the positive direction. I'm going to choose 0 on the ground and positive up because that's what I always do in free fall problems. Time equals 0 is going to be the instant it's released. Time final is the instant it hits the ground. P equals 0 is the ground. Positive direction is up. Time final, we know, is 0.4 seconds. The acceleration, since it's free fall, is negative 9.81 meters per second squared. The position at time 0 is positive 4 meters. You start at 0 and go in the positive direction 4 meters. P final is 0. And the initial velocity is what we want. We don't know anything about the final velocity, so this is everything. The equation that we're going to use is P final is equal to P initial plus V initial time final plus 1/2 A time final squared. So 0 is equal to 4 meters plus 0.4 seconds times VI plus 1/2 times negative 9.81 meters per second squared times 0.4 seconds squared. And so 0 is equal to 3.2152 meters. That's combining the first and third terms. Plus 0.4 seconds times VI. So if you move the second term over to the left side, you get 0.4 seconds negative times VI is equal to 3.2152 meters. And now divide both sides by negative 0.4 seconds. And you get an initial velocity of negative 8.04 meters per second. Does it make sense that it's negative? Yeah, because it's being thrown down and that's our negative direction. Does it make sense that the acceleration and the initial velocity have the same sign? Yeah, and gravity, as something's coming down, is going to be speeding it up. Okay, that's all.